Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to cover the topic of arc length. So we're switching gears from the previous, let it percolate. It's very important. You take the slope of something, how fast something is moving, okay, in the y direction with respect to x, and then you multiply by how far in x you actually go. So you're taking the slope, you're getting the delta y with respect to x, multiplying by how far you actually move in x, and that's going to give you the total distance, this distance traveled in the y direction. And just one more aside that I'm just thinking of off the top of my head. This is kind of analogous. This is just an analogy, so just bear with me. It's the analogy of taking miles per hour. What you're going to do here is you're going to take this thing. And I'm just going to go ahead and give you the answer at this point. I'm going to go ahead and circle the arc length formula. What we're going to do here, you see, let me just review the beginning and then I'm going to give you the final answer. What we've done here is we've taken this function and we've chopped it up into a bunch of little segments, and we all agree that the length of that segment is just equal to what the distance formula is. But then I told you that delta y was equal to the slope of this little segment times how far it actually goes over in x, which is just its derivative times delta x. And then I just do a little algebra to go ahead and whoops, what I want to say is this is the square root of 5, pulling out this constant outside the integral 1 to 5 of dx. And when you just integrate over dx with just the number 1 in there, is really all it's in here, 1, then the answer is going to be square root of 5. The answer is x. That's what you get when you integrate nothing in there, or integrate 1 really is what you're doing in there, evaluated from 1 to 5. Okay, so then you're going to have square root of 5, okay, and then you're going to have evaluating x at 5, you're going to have 5, and then evaluating x at 1, you're going to have 1, 5 minus 1, just plugging in here, subtracting there. And so you're going to get square root of 5 times 5 minus 1 is 4, and you always write the number out first, so you always say 4 times the square root of 5. So that's the answer, 4 times the square root of 5. So if this function that you were defining, if x were in inches, let's say, in this function we're describing the length of something or something in inches, then you would actually calculate this thing to find that 4 times the square root of 5 would be how long it is in inches. Okay, now the line, and that could actually be done with a ruler, but this is very difficult. So we know that the length, I'll just write it over here again, the length is the integral from a to b of the square root of 1 plus f prime of x squared, and then all under the radical, and then dx. So what we need to do is we need to find what that derivative is. What is that derivative? Okay, so let's do that right over here. We'll do it in another color. Okay, f prime of x is equal to derivative of x squared, and you could put this stuff squared under the integrand and under the radical sign and all that, but that's going to be, a lot of stuff under a big radical and everything. So what I like to do when I'm doing these problems is I like to go ahead and just do the squaring right here. So f prime of x, let's go ahead and square it and see what this equals. Okay, so we're going to square this right here. Now this is just 2 times x minus something else over here. So the way you can do this is you square the first term. So 2x squared is 4x squared. Okay. Okay, and then you go plus 2 times squared minus 1/2 plus 1 over 64x squared, and all of this stuff's under the radical, and then I have a dx. Now this certainly doesn't look good. It certainly does not look good at all. But let's go ahead and just add our 1 and subtract our 1/2. So it's going to be the integral of 2 to 3 square root, and then I'm going to have 1/2 plus 4x squared plus 1 over 64x squared dx. Okay? Okay, the next thing I'm going to do anytime I have a polynomial, even though this is an ugly polynomial, is I'm always going to rewrite it with the x squared term first. So it's going to be 4x squared, and then I'm going to have plus 1/2 in the middle, plus 1 over 64x squared right there, okay, dx. Okay, so what's going to happen in these problems, okay, 99.9% of the time, because you have this radical in every single problem, if you do it right, normally you're going to get something that you're going to be able to factor and then take the square root of easily, and it's going to make you squared. So this is just your integration of a polynomial, 2 over exponent plus 1 x to the exponent plus 1. So 2 over 2 x squared. Notice when I do this, I just write 2 over 2. I mean, I could do it in my head. It's going to be 2 over 2, and that's going to give me 1, and I could just write a 1 here. But when you're tracing back through your steps, it's really helpful to have everything on your paper. So I do it just this way, you know, in my own work, okay? Plus, 1/8 is a coefficient to 1 over x, so it's 1/8. And the integral of 1 over x, you should remember, is the natural log of x, okay? Factor out the 1/8, okay? I'm going to say plus 1/8, okay? And I'm going to factor it out like this, natural log of 3 minus natural log of 2. All I did was take the 1/8 that's common and pull it out, and I'm going to have what I've left over in here, natural log of 3 minus natural log of 2. You can do this multiplication and see that this is exactly right, okay? And then what I can do, if you remember back from your logarithms, anytime you have the log of a number minus the log of another number, you can write it as a fraction. So the answer is going to be 5 plus 1/8 times the natural minus 1 over 8x, and then we take the square root of the derivative, and we got, you know, this expression right here, okay? So we put that into the radical. I have to add the 1, obviously, because that's under there. And then we did a little bit of simplification, and we arrived at this. Now, what you want to do when you get to this step in your problems is you always want to see if you can factor it into something that you can take the square root of, because the square root is just going to be the obvious the obvious problem here. To take the integral of something with a square root is generally tough, so you really like to get rid of it if you can. This was able to be written as the multiplication of 2 identical terms, so we could write it as something squared. Multiply in. X squared times x squared is x to the 4th power, plus x squared times 2 is just 2x squared. Okay? Now, I'm always going to rewrite any polynomial like this with the highest powers first, because it always helps me figure out if I can factor these things. So it's going to be square root of x to the 4th power plus 2x squared plus 1, and it's going to be dx. Now let's see if we can factor it. That's the magic bullet here. We want to see if we can factor this thing. Integral from 0 to 3